Hello and welcome to this quick walkthrough of our new greenSlab program. My name is Christian and I'll be walking you through the different features of our new slab program. When you come to our website, the first thing you'll have to do is log in with your credentials. So I'll quickly do that. Once you're logged in, you'll be presented with the overview of calculations that you've been working on. And here you have the option of adding either calculations to some projects you've already been working on or adding entire new projects. For this, I'll be adding a test project and giving it some kind of number. You can later use this to locate your old projects and calculations in the database. Simply press add project and add calculation. And you have the option of adding a calculation to that project. So you'll see the project name here at the top. I'll choose the greenSlab program as that's what I'll be showing you today. We'll give that calculation some kind of name. Just call this one test lab. And you also have the option of adding instructions to your calculation. Now the instructions are pieces of text that will be added to the documentation once you print the calculation. So that could be anything from design assumptions to whatever you feel is relevant to add. I'll not be filling out anything here now, but you can if you want. Then you could just press add and go to calculation, and they'll take you to the calculation page. Here you have the program. It's a very easy user interface. You simply start out by filling each of these accordion from the top to the bottom, and that will get you your calculation. Here at the top, you'll see the selected project name and calculation name, along with the option to edit the instruction that you said earlier. Now, starting from the top, you simply define the analysis parameters for your slab. Here you have two options. You can design it as per the TR34, that is the Technical Report 34 from the Concrete Society. That's an industry standard guideline towards designing industrial floors. The other option is the standard Eurocode 1992. Of course, the TR34 does follow the Eurocode, but in certain aspects, it's not quite as conservative as the strictest interpretation of the Eurocode. So that gives you the option. You also have the option of selecting the national annex. For now, we only have the Danish annex here, but we will soon be adding support for other kind of annexes. Finally, you can define your allowable crack limit. Typically, that'll be something like 0.4. Geometry, you define your slab thickness and dimensions. So as an example, I'll do a 120 millimeter slab. Maybe that slab is 25 meters by 25 meters. What you'll see is you'll get a little text saying that that's a very large bay size, and you may have shrinkage cracks and something like that. And you should be considering maybe having some joints in that slab. So you have that option as well. And you can define joints such as a size like 6 by 6 meters, and then you'll not see that warning anymore as shrinkage cracks are no longer expected. You also have the option of defining what kind of joint type you have. The default will be saw cut, but you can also do a custom, which then allows you to define a custom load transfer in percentage up to a maximum of 50%. So if you're working with a joint supplier, they can provide you this value. And in the future, we hope to have some more joint options available, either from specific suppliers or just some standard solutions like dowels and whatnot. For this, I'll just stick with the saw cut option. Material properties, you define your concrete quality along with cement class. These days, rapid cement is by far the most common, but you also have support for Class N and Class S, which are lower shrinkage potential concretes. If the relative humidity is known, you can type that. Otherwise, you can specify what kind of environment, and then it'll use a default value, such as outdoor, which will assume an 80% relative humidity. Subbases, it's of course a very important part when you're designing slabs. You can add one or more subbases here. You simply click add, and then you'll get this option. You can specify a name and some properties for your subbase. In this case, I'll just call it layer 1. You have the option, either if you know the stiffness, the modulus of subgrade directly, you can type that in. Otherwise, you have some options you can fill out. Is it a ground or is it an insulation type layer? If it's an insulation, you also have the options of choosing some predefined values from the Sunderlit insulation libraries. Can make it a bit easier rather than having to look up values. Otherwise, you can type in the long-term compressive strength, thermal conductivity, etc. of your chosen insulation. For now, I'll just quickly use an S60. And maybe if we have a 300 millimeter thick layer of that. You can then possibly add multiple layers, such as maybe we know that the ground below is well compacted sand. If you choose some of these predefined options, it'll use some default values for the modulus of subbase for that type. Otherwise, again, you can type in some data for your layer, and it'll use that instead. But for now, we'll just assume we have some compact sand. And it'll then use the combined stiffness of those layers. And of course, that'll very much be governed by the softest layer, which in this case is in the insulation. As for the loads, here you can similarly add the loads that are relevant. You could give it a name, test load, and then you have 3 options here. You can either define it as a concentrated load, a line load, or a uniform load. A concentrated load will be like a point load. It could be an axle load, or it could be a quadruple type load. Quadruple could be perhaps a vehicle, but also perhaps racking loads. Yeah, dual type, classic axle load, or if you just have a point load, then that's an option too. Again, line load, you can specify a line load. Uniform, it'll specify some uniform distributed load. Here, I'll just do a test load, maybe 10 kilonewton load. Or maybe in fact, let's make it a dual load. So we'll have maybe a 15 kilonewton axle load. You can specify as per the distribution diagram. You can see what you have to define. Well, the load distance was then the distance between each wheel. So perhaps we have 1500 millimeters of that. And we're going to define the shape of the loads, the wheels, as you will. Either circular, rectangular, and then you define the dimensions for that. I'll just do 100 by 100. Also gives you an option of defining whether you know the position of the load or not. If you do know it, you can specify the distance exactly of that location. It's specified in terms of the distance from the corner, which is one of the most critical location of a load. And you can also specify if it's located at internal joints or not. If you say it's unknown, it'll automatically try to locate it at all possible positions on the slab. You'll also define add predefined loads. There'll be a list of the standard Eurocode loads, which typically includes a UDL load as well as a point load. So, for example, we can choose D1 for shops and add that load, and it'll automatically fill out the data. So here you have the UDL for the D1 type load, as well as the point load associated with that. Now, it should be noted that all loads are currently including any load factors. So this would be a characteristic load of 4 kilonewton, and then there's the load factor of 1.5. Those you have the design load of 6 kilonewtons. Yeah. So that's the load tab. Reinforcement, very easy. You can specify any fiber reinforcement you may have. This is of type Durs Easy Finish. Then you can specify any steel reinforcement, either it's additional to the fiber reinforcement or instead of. Here you can define your steel class and quality, as well as the cover layers. And then you have the option of either defining a reinforcement across the entire slab, or local at maybe edges and corners. In case you have a movable load, then critical positions would be at the edges and corners. So rather than reinforcing the whole slab, you have the option of just reinforcing the critical area. So for this example, maybe let's say we have some top mesh reinforcement of 8mm diameter and 150mm spacing. Once all the tick boxes say you're good to go, you can look at the results here at the slide out. And what you'll see is for each of these loads, it'll list the load that you've typed in, along with the punching load, the bearing capacity, offset load, as well as the punching capacity. And out here, you'll have the utilization ratio, that is the load divided by the capacity. So in this case, you'll see that the test load is highlighted in red for the corner position, meaning that this position, the load would not pass. All critical positions that doesn't pass the design check would be highlighted in red like this. Also, you can see the plan view and the diagram of what your slab. So here you'll see an indication both of the field size you've chosen, 6 by 6 meter, in relation to the total size, 25 by 25, and an indication of this edge area where you've specified a different kind of reinforcement, as long as the edge distance where that needs to be reinforced. You also have this cross-section diagram where you can see exactly what you've chosen along with each layer for your sub-base. So in this case, we have purely fiber reinforcement in the center here, whereas we have an edge, we have a special added reinforcement here as indicated. We can try to specify, as we noticed here, it was only in the corner that the design didn't pass. So perhaps we can add, say that, well, perhaps the 8 by 150 isn't sufficient in the corner. So perhaps we do a 10 by 150 for the corner. And then we should see that this is now all pass, and instead now the highlighted load is the most critical. So, but it's no longer red, meaning that it does pass, but that's now the uniform load at the internal position. The next slab, or sorry, rather the next tab, is the CO2 calculations. The CO2 calculations give you an overview of the CO2 emissions of your entire slab, as well as a comparison relative saving compared to sort of a list of predefined slabs. This references is currently rather crude, but it is a list of slabs where the applied loads that you have chosen would be tested against. And then it will basically say, well, you could perhaps do this design with a different kind of reinforcement that would lower your CO2 emissions. In this case, it's say, well, actually your thickness of 120 is actually larger than it needs to be. It does pass with this design of 100 millimeters with 6 by 150. Yes, so that's the CO2 emissions. It does also give you the links to the EPDs from which the CO2 emissions are based. Note that, of course, EPDs are very much dependent on both location and your supplier, so they'll vary between where you are in the world and what kind of suppliers you have available. But these are representative of at least materials in Denmark. Finally, you have the option of the insulation calculations. That isn't a property that might be, you can save a lot there by maybe choosing a stiffer or a better insulating property material. If you have a insulation of higher insulating value, then perhaps you can reduce the thickness. Reducing the thickness also increases the stiffness, thus perhaps allowing you to reduce your slab thickness instead. So in terms of minimizing your CO2 emissions, the sub-base and insulation strength can be a property that's worth optimizing. So in this case, I increased it, thus getting a better U value. Now that you've done your design, everything passes. Also, should add here in the top, you have the shrinkage calculations. If you have chosen a design which is susceptible to shrinkage cracks, then it will say here what the expected shrinkage crack width is. But in this case, we have a small base size, so there should not be an issue. At the bottom here, then, you have the option of saving your calculation. The Save button will save an entirely new revision. You'll see here we only have one revision right now, but if you want to save a new revision, the Save button will do that. Otherwise, there is always live saving as you use the program, so that it'll always update the current revision. But if you want to, if you've done larger changes, then maybe you want to save the revision, so you can always go back and see, backtrack your changes. There's also the possibility to save it as an entirely new name. So if you have a slab that you maybe for different parts of the same project, maybe one building has a certain thickness of slab and another has a different set of loads and thus a different slab, you can just save a copy of the calculation under a new name, and that'll appear in the database. Finally, of course, you have the print button. The print button will then generate the PDF of your documentation. It'll have the project name. It'll have the name of your calculation, as long as the ID of the designer. Here, it'll have your company details, the company logo as you've uploaded it, and then it'll show your table of content of what is in your calculation. So from the start, it'll say the geometry as you've defined it, your material properties, your sub-base properties, for each of the layers as you've defined it, what are the stiffnesses, the diagrams of your choices, here the internal cross-section, here the edge cross-section, and also the corner cross-section, and of course the plan view specifying what those areas actually mean in terms of the overall slab. Then it'll list the shrinkage calculations, the crack width calculations, and the global stiffness parameters that it'll use for the bearing capacity calculations. The table shows an overview of the loads and the capacities of calculation, highlighting the most critical. And then it'll show you the verification of said critical load. In this case, the most critical was an uniform load, thus it'll not show any punching checks, as that's not governing criteria for a UDL, but it'll show the detailed calculations of how that capacity is reached. Finally, you have the CO2 calculations to wrap it all up, and then a bibliography of references in terms of how some of these capacities have been derived. Finally, back page, and you're all ready to go. And you simply click print here, and you can print it as a PDF or even as, with your actual printer. Yes, and with that, I think that concludes this little walkthrough of our program. I hope you found it useful, and see you next time.